Hello friends, myself Professor Fayyaz Khanadi from Department of Mechanical Engineering. In the today's session, we are going to discuss what is the path of contact, the formula for the length of path of contact, and we are understanding these two concepts by solving one numerical from theory of machine subject. The problem statement is that two matting gears with module of 6.5 mm have 19 and 47 teeth of 20-degree pressure angle and 6.5 mm addendum. That means the module of both the gears is 6.5 mm. Two gears in which one is smaller and one is larger. So smaller gear is having number of teeth is 19 and larger gear, which we can say as gear, having teeth 47 numbers, and both the gears is having pressure angle 20 degree, and the addendum value for both the gears is 6.5 mm. And after that we have to find out length of path of contact, second length of arc of contact, and third contact ratio. So before solving this numerical, first of all we have to understand what is path of contact. So path of contact is defined as the path traced out by the point of contact of two teeth from the beginning of engagement to the end of disengagement of same gear tooth pair. Here in this figure we can see that is the profile of pinion smaller gear, and this is the profile of larger gear, and F is point of contact of both the teeth. After some time, a rotation, when gear 1, that is nothing but pinion, is rotating by clockwise direction, when pinion is rotating by clockwise direction, at the same time gear will rotate by anti-clockwise direction. So after some time, that profile of pinion CM will take new position DN, and the profile FM, this profile of gear will take new position, this new position, as I am showing by arrow. So F is the point of engagement, and after some time both the same teeth will disengage, and E is the point of disengagement. Obvious F and E, this F and E is contact point for both the teeth profile. So F is the point of engagement and E is the point of disengagement. So FEF, which is measured along common normal line, this is common normal line AB. AB is common normal line, perpendicular line to both the base circle. This is the base circle of pinion and this is the base circle of gear. So the line which is drawn tangent to both the base circle is common normal line. AB is common normal line. So the point of engagement F and the point of disengagement of the same tip, which is measured on common normal line, is nothing but path of contact, FE. In another word, length of path of contact is the length of common normal cut by addendum circle of both the gears. That means common normal line AB is cut at point F and E. This is addendum circle of pinion. See, all the gears have basic three circles. In this figure, we can see inside diameter, that is nothing but a base circle. Outside diameter, that outside diameter is addendum circle. Addendum circle. And in between that circle is pitch circle. Pitch circle. So pinion is having three circles: base circle, pitch circle diameter, and addendum circle diameter. Gear is having base circle, pitch circle diameter, and addendum circle diameter. And P is the point of contact, and that P is on always pitch circle diameter of pinion and pitch circle diameter of gear. That means P is the common point of tangency. Both the pitch circle meet at tangent point. That point is a P point. So the addendum circle, this common normal line is cut by addendum circle at point E, and this common tangent line, common normal line is cut by addendum circle of gear at point F. So when the AB line, which is common normal line, when that common normal line is cut by both the addendum circle of pinion and addendum circle of gear, that distance is called as point of contact, EF or FE. Okay, this is point length of path of contact. So from the figure, FE is the summation of the portion of PF and PE. PF and PE, summation of EF is the summation of PF and PE. So PF is nothing but path of approach when gear is rotating by clockwise direction and pinion is rotating by anti-clockwise direction. So FP is the distance, is called as path of approach, and PE is called as path of recess. Here we can see path of contact is equal to summation of path of approach plus path of recess. Now come to the derivation part of length of path of contact, and now we are going to derive this formula. What is the formula for length of path of contact? Let small r is the pitch circle radius of pinion. This pitch circle radius of pinion, this is pinion, and we are using capital R is pitch circle radius of gear. As gear is having larger diameter, so we are using capital letter R, and pinion is of smaller diameter, so we are using small letter R for pitch circle radius. RB is the base circle radius of pinion. This RB, base circle radius of pinion, and capital R suffix B is the base circle radius of gear. This is base circle radius of gear. Small r suffix a is addendum circle radius of pinion. Ra here, this addendum circle, this is radius of addendum circle, small a for pinion, and capital R suffix a is addendum circle radius of gear. So capital Ra and small ra is the addendum circle radius of gear and pinion respectively. Phi is the pressure angle. Here we can see in previous video we have already discussed what is pressure angle. Pressure angle is the angle made by common tangent line to both p circle radius, and common normal, common perpendicular line to the base circle. So angle made by AB, AB is common normal line to the base circle or both the base circle. This is base circle of pinion, this is base circle of gear, and common line which is drawn to the base circle is AB is common normal line. So the pressure angle is nothing but angle made by common tangent and common normal line. Now length of path of approach FP is FP. First we have find out length of FP. Okay, so for finding length of FP, we are considering triangle O2AF. FP, we are considering the triangle O2AF. So FP is AF minus AP. Here I have already written here FP is equal to AF minus AP. AF minus AP is equal to path of approach PF. So for finding PF, we are considering triangle O2AF, this triangle O2AF. So first of all, we are finding AF from this triangle. So from the Pythagoras, already we have learned this is 90-degree angle. AF is perpendicular to O2A, so this is 90 degree. So this is a right angle triangle. So according to Pythagoras theorem, AF is equal to under root hypotenuse O2F minus O2A. So O2F is nothing but capital RA. This RA is this radius. O2F is equal to this RA. So putting the value of O2F is R suffix A, capital R suffix A square minus O2A. Now we are going to find out value of O2A. So for finding out value of O2A, we are considering the triangle O2AP, this triangle O2AP. Again, this is a right angle triangle. We are taking the relation from trigonometry. Cos phi, this angle is phi. How? If these two lines TT and AB is making angle phi, so perpendicular to these two lines also making angle phi. So perpendicular to TT is PO2 and perpendicular to AB is O2A. So if these two angle making angle phi, these two lines is making angle phi, so perpendicular to these two lines is also making angle phi, that is same angle. So this angle is phi. So cos phi is equal to O2A O2A adjacent side divided by hypotenuse O2P. But O2P is nothing but P circle radius for gear capital R. So O2A is equal to R cos phi. O2A is equal to multiply by this R into cos phi. So O2A is equal to R cos phi. So putting that value of O2A in equation number 2, so AF is becoming under root capital R square minus capital R cos phi. This R cos phi O2A. In this equation, this will under root by according to Pythagoras theorem. Next, from triangle O2AP, so this will become our AF. AF in equation AF, we are getting that AF. Now we have to find out value of AP. So for finding out value of AP, again we are considering the same triangle. Okay, O2AP here. O2AP sin phi is equal to AP divided by O2P. Sin phi is equal to opposite sine AP divided by hypotenuse O2P. But O2P is nothing but again capital R. O2P is capital R. So value of AP is equal to R sin phi. So putting this value R sin phi in equation number 1, so FP is path of approach is equal to this value is AF, and this is AF minus AP. Here is AP. This is AP. So formula will become here under root RA square minus capital R square cos square phi, and after minus capital R sin phi. This is out of square root. Okay. So path of approach. Now we have to find out length of path of recess. So this is path of recess PE. PE is path of recess. FP is path of approach, that we have already find out. PE is path of recess. So for finding path of recess, we are considering triangle O2BE this time. O2BE. In O2BE, this triangle, EP is equal to EB minus PB. Correct? EP is equal to EB minus PB. So again, this angle is phi. O2B and O2P. These two lines is making angle phi. O2B is perpendicular to EB. So this angle is 90 degree. So again from Pythagoras O2PP, this triangle Pythagoras, we have to find out EP. So EP is equal to under square root hypotenuse minus O1P. So we can see here, according to Pythagoras, O1E square minus O2B square. O1E square minus O1B square. So O1E is small ra. O1E is small ra. This we can see the small ra. Addendum circle radius for pinion. This same here. Okay. EO1. So this is RA minus O1B square. Now we have to find out the value of O1B. So consider triangle O1BP. O1BP, O1BP. P. This triangle O1BP. This is phi. Okay. So cos phi is equal to O1B divided by hypotenuse O1P. This O1P is nothing but R, pitch circle radius for pinion. Okay. So O1B is equal to R cos phi. Putting the value of R cos phi in equation number 2. So we are getting the value of B is under root RA square minus R cos phi bracket square. Now we have to find out the value of BP. Now we have already found out value of BE. Now we have to find out value of BP. So we are considering triangle O1BP. Again, same triangle O1BP. O1BP. We have to find out value of PB. PB. This PB. Okay. This PB is opposite side of phi. So we are using the relation of sin phi is equal to PB divided by O1P, where O1P is again small r, which is nothing but pitch circle radius of pinion. So putting the value of O1P is small r, so PB is equal to small r sin phi. So putting the value of PB in equation number 1 again, PE is equal to under root small r a square minus r square cos square phi in under root minus small r sin phi. So this value, this formula is the formula for path of recess. So for remembering the formula of path of approach and path of recess in the examination, we have to remember that in path of approach formula, all the values of r is capital R, path of approach. This is capital R. This is addendum circle radius of gear, pitch circle radius of gear, and here again pitch circle radius of gear. In path of approach, we are using the addendum circle and pitch circle radius of gear, and in path of recess formula, we are using addendum circle of pinion and pitch circle radius of pinion. That is the difference that you have to remember while writing the formulas. Now come to our actual problem. Model is given 6.5 mm for pinion and gear. Number of teeth of pinion, that is not given in question, but only the teeth of wheel is 19 and 14 is given. As pinion is a smaller diameter wheel, so we are assuming that 19 is the teeth of pinion and gear is having larger diameter, so teeth on the gear will be more as compared to pinion. So we are assuming that 47 is the teeth of gear and 19 is the teeth on pinion. Pressure angle is 20 degree and addendum is given 6.5 mm. First of all, we have to find out length of path of contact. We know module is equal to a ratio of pitch circle diameter divided by teeth on wheel. So from this, module is equal to, if we have to find out module on pinion, so dp, pitch circle diameter of pinion divided by tp is equal to dg, diameter of gear, to the teeth of gear. So first of all, we are going to find out diameter of pinion. So module is equal to d by t of pinion. So number of teeth on pinion is given 19. So diameter of pinion is coming 6.5 into 19 is equal to 123.5 mm. When the diameter of pinion is 125, so radius of pinion will become half of this 123.5 is nothing but 61.75 mm. So this is the radius of pinion. For that we are using small r, radius of pinion, pitch circle radius of pinion, and pitch circle of a gear, we are using capital R. So module is equal to dg by dp, dg is equal to dg by number of teeth on gear is 47. So dg will become 305.5 mm. So radius of gear, for that we are using capital R, is equal to 152.75 mm. So pitch circle radius of gear is 152.75 and pitch circle radius of pinion is 61.75. Now RA is equal to, in the formula we have required capital RA and small RA. So small RA is addendum circle radius of pinion. This A is addendum circle of pinion and small r is for pinion. So RA is equal to R, this R is circle radius plus addendum. So addendum is the distance measured on a radius from pitch circle diameter on up to addendum circle diameter. This is addendum circle shown in green dotted line. So this is addendum measured along a radius. This is addendum, or you can see in this figure addendum. So R plus addendum A is become RA. This is RA, addendum circle radius. RA is equal to pitch circle radius plus addendum is given 6.5 mm. So it will become 68.25 mm. And capital RA is equal to pitch circle radius of gear plus addendum, this addendum of gear. And for both gear and pinion, addendum value is given same 6.5 mm. So R pitch circle radius is 152.75 plus addendum is given 6.5 mm will become 159.25 mm, 25 mm. So path of approach is the formula for path of approach that we have already seen. And now I am putting the value of RA, R and pressure angle phi. 159.25 square, here 159.25 square minus R cos phi bracket square, or you can write here R square cos square phi, R square cos square phi 20 degree. These value are under root minus R sin phi. After calculating, we are getting the value of path of approach. FP is equal to 16.73 mm. I am giving here the YouTube video link for understanding the addendum, what is addendum, in my previous video. So you can see this previous video for understanding what is addendum. Now path of recess, the formula for path of recess we have already discussed. So value of RA is 68.25 square minus R cos phi bracket square R square cos square phi. This value is under root minus small r sin phi. So after calculating, we are getting the value of PE is equal to 14.81. So PE, path of approach plus path of recess, summation of these two values is nothing but path of contact, EF. So by adding both the values, we are getting the value of path of contact is 31.54. Thank you so much.